Hello, welcome to Cloud Field Day number 6. I'm Neil Stanley. I'm a product manager for the Data Fabric. I'm going to go to this section on an overview of our Cloud Data Services products. So Cloud Data Services is a new business unit, or a relatively new business unit within NetApp. It doesn't sell hardware, but uses our services to layer on top of our hardware offerings to make them more cloud friendly. So some of our first products that we deliver to the market, or the key one that becomes the atomic measure of the building of a data fabric, is cloud volumes. So the cloud volume service, it's in the Microsoft world, it's called Azure NetApp Files, known as ANF. But in GCP and AWS, we use the Cloud Volume Service brand name, and I'll get into what's next after that, where we're recently announced some additions to that and those capabilities.
I'm curious. Since there's a difference in naming between what runs in Azure and AWS and GCP, is there also a hardware difference on what's backing the cloud volumes versus Azure NetApp Files?
They're all the same. They're the stamp that we use the word stamp. It's the physical footprint of all the hardware. In each data center, they're all the same AFF, NetApp all-flash array, or all-flash FAS, and some of the nuances of the actual data centers stipulated that we needed certain switches at the top of our rack. So there was, in certain PDUs, like Microsoft specifically had standard power distribution unit that needed to be in the rack. So there's irrelevant differences, but the service itself and the API that orchestrates it is all the same.
I know the consumption model for Azure, you still provision it via ARM, so or the API. Do you also provision cloud volumes via CloudFormation or whatever GCP's version of it, or is it a different consumption model for that as well?
So there is a model within GCP where they are interfacing directly with our CVS API. So GCP are writing their own front end to that, which talks to our backend API. So whereas in the AWS space, to create a little bit different differentiation, when you're participating in a marketplace, AWS doesn't give you a front end portal. So we've provided our own front end, and that's tightly integrated, obviously, to our own backend API. So that is, they're all known as Cloud Volume Service, and we'll talk more about how that's going to change in the new interface and the new services coming out.
That was my follow-up question, but it sounds like you're going to get there. So I'll stop.
There's a what's next section in there. So going back to the slide again, looking at Cloud Volume Service and Azure NetApp Files, this is the kind of the realm we exist in. So we're handling the storage services for the hyperscalers. Obviously, the hyperscalers provide their own virtualization mechanisms and all that kind of stuff. We rely on their networking capabilities. That we do automate some of that from our side of things to present our data protocols over the right kind of VLANs, which integrates with their automation of their network stack. So those are it's in a red box over there because it is NetApp managed. We remotely access our own equipment to make sure the lights are still on, do all the care and feeding, do all the capacity management, and send out new shelves whenever necessary, and expand the clusters. In the other service that Cloud Data Services created was actually on the same day that we acquired a company called StackPoint Cloud, we released this NetApp Kubernetes service. So the NetApp Kubernetes service, with an announcement that was done in the June timeframe, now has capabilities to deliver Kubernetes clusters and build Kubernetes clusters on premise on various virtualization layers. So if you're not too familiar with Kubernetes and how it manages containers or what their purpose is, we'll get to some of that at the end. The last section is actually goes into much more deeper about NetApp Kubernetes Service and its purpose in our data fabric. So we also provide NKS on HCI, which actually is using our hardware. So this is an instance where one of our hardware business units is providing on-prem capabilities with this part of the stack, and NKS is layered on top of it, which orchestrates Kubernetes and essentially provisions these kind of platform level pieces, so that customers don't have to manage this. Even inside a hyperscaler, these things all become managed and automated, and they can come to NetApp's NKS portal and not have to worry about these pieces. All they have to do is provide their application or the container to be orchestrated and created on NKS. So in that scenario, NetApp manages all those capabilities from a single portal and provide that service. Another permutation, which will be released soon, is marrying up the next piece of the puzzle of having NKS on HCI with the storage being orchestrated by Cloud Volumes. So once we have that, then we get a tighter integration with the other APIs that we've got in the hyperscalers and start being able to participate in the Cloud Volumes data fabric kind of ecosystem. So we provide our Cloud Volume API and then orange box on the storage layer running on tap select on top of HCI. This was one of the new services where we're expanding the human effort. We're providing the actual services with the same team that does it in the hyperscalers. So we've kept the same CVS, and we've changed this color to green because it is vendor managed. We become the vendor of the storage. The asset belongs to NetApp, even if it's on a customer's on-prem environment. So this is the same subscription model as they would get in the hyperscalers, and it provides, again, just an ease of use. It works across the multi-cloud environment, and all of that is consumed and orchestrated by the fabric.netapp.io software as a service, which was announced in June with a name called Data Fabric Orchestrator. There will be a name change coming at our Insight conference to give it a more holistic view of what it really does. And expanding a bit more just to give you a better look at where the differences between Cloud Volume Service and having the Cloud Volumes API. Obviously, the hyperscalers use the API. We run it as a service in the hyperscalers, and when we're in an on-prem environment, we can use the API when it's on a NetApp HCI platform, or consume it as a whole service using the CVS on-prem features.
So I'm sorry, I might be missing some context. You go back a couple of slides.
This one?
So CVS on-prem.
Yeah.
I'm missing how is it delivered? Like, am I consuming that? In what financial model am I consuming CVS?
Yeah. So I will get to that financial model because there's a specific consumption basis for that again protects customers from that OpEx versus CapEx mechanism, and it is an allocation model. We use the term capacity packs to say if the customer buys a pack of X number of terabytes, then they consume that by creating volumes. I'll go into much more detail further down about how Cloud Volume Service for on-prem is is monetized from our point of view, what the sales motion is for customers, and how it's used via the Fabric orchestrators, as well as how it's supported. But I think the answer to your first part of the question, the hardware stamp that actually gets put into an on-prem environment is literally the same as what is provided in Microsoft. We're using the same switches, the same PDUs, all the remote management is using the same tool sets. But what we get in the hyperscalers is the ability to use the hyperscalers' compute layers to run our API on. Whereas on-prem, no one's going to give us compute for free necessarily. We don't want to rely on our service being predicated on the availability of a customer's compute infrastructure. So we're actually bringing in our own, and we're actually using our own HCI compute equipment as the compute layer with its virtualization. It's using NKS, so that NKS on HCI pieces is a part of the puzzle to make Cloud Volume Service on-prem function, because we're delivering the Cloud Volumes API actually as a container running on top of NKS. So there's so many worlds colliding.
So when I'm speaking of worlds colliding, I get the model of you guys managing Cloud Volumes on-prem. We're maturing as an industry to kind of have these carve-outs on-prem.
Yep.
I even get the concept of NKS on-prem.
Yep.
One gap that I hadn't heard yet is the NKS as a service. NetApp doesn't run data centers. Correct. So to speak. So where's NKS running when I'm not consuming it on-prem?
Yeah, it's a good question. I'll go back to this picture here. So NKS, so this isn't the NKS necessarily on HCI. This virtualization layer on-premise could be a vanilla VM, where it could be one of our FlexPod infrastructure, but it runs on top of and orchestrates the creation of virtual machines on any flavor of VMware. In the hyperscaler, the virtualization layer is handled by the hyperscaler. It's their permutation of whatever hypervisor they want to use, but the NKS cloud talks to the APIs delivered by the hyperscaler to create their virtual machines in the instance size and shape as what's necessary to run all these pieces, so that we can have containers running at the application layer instead of traditional kind of applications.
So the NKS control plane is running somewhere managed by NetApp, and then when I say, you know what, I want to provision a cluster in some pods.
Yeah.
You guys, let's say in the case of AWS, will deploy EC2 instance in my target VPC, and that provisioning is invisible to me.
Correct.
But I get the cluster and the pods that I want.
Well, all we need is your credentials to your VPC, so that we can spin up those virtual machines, and your VPC hosts them, and you're paying for that cloud resource, but we're orchestrating the creation of it in the instance size necessary to run your application that you can define via the install routine.
So go on. I'm sorry, Ned. One last question.
Go for it.
The connectivity to the cloud volumes from that point. So obviously there has to be some network plumbing that has to happen for my NetApp hosted cloud volumes to get persistent storage from my pods. How is that managed, or how does that happen?
So you mentioned that the Cloud Volume Service in the hyperscalers.
In the hyperscale. So this is all hyperscales.
Yeah.
Like on-prem, this is pretty easy.
Yeah. So at that layer, when Kubernetes needs storage, it puts a claim out there called a persistent volume claim.
Right.
And we have a product called Trident that will respond to that claim and go and make it happen. As part of its process of making it happen, it will interface with the Cloud Volumes API and go and establish an actual cloud volume using the NFS protocol. And once that's mounted and it's got an IP address and a mount point, Trident basically sits there and waits for the response to come back to say, here's your persistent volume, and Trident tells Kubernetes, I've responded to your claim, here's your persistent volume, and connects that into the operating system layer as the mount point, so that, and then Kubernetes orchestrates the delivery of that mount point within the VM into the container.
So Trident does all of the cloud API and that I need to say that cloud volume exists somewhere.
Yeah.
Go here are all the IP tables or whatever the ACLs needed to go out and get it. Go, this is where it's at. Kubernetes now, the Kubernetes persistent service takes it from there.
Yeah, basically, Trident will essentially talk to the storage, because this is where our cloud volume service is living at this layer. I should overlay the pictures, but here's Trident would be talking to this and the storage layer to present the actual cloud volume, the provisioning of that, like the IP address of the mount point, all kind of stuff. That actually, in the hyperscalers, comes from the cloud volumes capability of talking to the hyperscalers networking layer. Trident doesn't go out and do that. It doesn't talk to the hyperscalers directly. Trident just talks to the cloud volumes.
Yeah, so from a cloud volumes perspective, cloud volumes gets its IP and all that from the hyperscalers.
Correct.
But inside of my VPC as a DevOps guy, when I'm DevOpping, I don't necessarily want to go and do the plumbing to say that the instance that was created can talk to cloud volumes, etc. Trident does that on my behalf.
Correct.
The question.
Yeah, Trident does have some configuration. It needs to be told what to talk to, because it can literally talk to everything. Like it can talk to our element operating system on SolidFire. It can talk to cloud volumes, the different flavors of cloud volumes. It can talk to E-Series. It's been been made capable. It's been around for a while to actually have all that work done on it. So does that answer your question?
Absolutely.
Yeah. Very.
Thank you.
I
think Ned had a
too.
Yeah, go for
I've
it.
got a follow-on question after Ned, but
Great. So we got lots of questions. This is fun. In terms of provisioning Kubernetes on the hyperscalers, is there a reason you chose to deploy your own Kubernetes cluster using their IaaS primitives as opposed to just using one of the Kubernetes services on, like, say, EKS on AWS?
Yeah. So that's a great question. There is a very good answer, and it's for portability, and the fact that we don't modify the Kubernetes base, or the distribution of Kubernetes is always current with whatever the open source project is at. We support the latest and two revisions back, but we don't touch that code base to make it our own, whereas other Kubernetes services, like name them all from the hyperscalers, they're kind of their own flavor, because they've taken Kubernetes as an open source thing, made it their own, and when they need to update, or if Kubernetes releases something, there's a lag in actually getting their versions updated, so that any new features, even security patches and all kind of stuff, take time to get to the capabilities of the layer that the customers care about. And by taking that approach of having it portable and not modifying it, means that it behaves the same everywhere. So it actually lends itself to the data fabric story even better, because the portability of applications from one hyperscaler to the other doesn't require any modification if it's all on that same generic vanilla NKS layer. And they're great questions on NKS. We have a whole section on NKS at the end, and I've already answered the question.
Mine's a very quick and easy question. At first, when you went through the slide, I'm like, oh, this is really cool. We've got the you manage and NetApp manages part. And then after Keith was asking us questions, what is because NetApp manage overlays on a lot of what you manage. What exactly is the NetApp manage part? If in that, basically in that, that red bubble there, that red box.
Yeah. So the NetApp managed part is essentially, I suppose, like ring fenced to encompass these boxes, because obviously hyperscalers are managing these, and these are essentially customer assets. Even this pink box is a capital purchase of HCI, because that's not a subscription-based purchase. So if these are still customer managed, they can still subscribe just to the SaaS service, just to the NKS in the cloud, and use it at this layer. And then everything within here is essentially black box to the customer, for lack of a better word. It's they don't have to touch any of these layers because Kubernetes will do it.
To the point of like what you were saying to Ned, it's that you maintain the consistency of that portion of it.
Correct.
So, okay.
Yeah. Exactly.
But customers could choose to just leave the whole box, just have that stamp roll in and leave it a black box and let you guys manage it? Is there an... Okay.
Yeah, so it's all, these layers are all API driven. So this pink box, even the storage that's on here for the sake of the other picture where it's actually, Cloud Volumes, that orange box, that's the Cloud Volume API. And that's ONTAP Select being orchestrated by the same Cloud Volumes API as in the hyperscalers. So it's making this look like a lot more closely aligned to a private cloud, given that so much of it is automated. But that's not.
So going deeper in the, I'm sorry, Arthur.
Go for it.
Well, I'm not going to say one last question. This is fairly interesting. The replication between the on-prem, the infrastructure platform service, blah, 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 blah.
Yeah.
Between the different hypervisors. I'm an ONTAP administrator, and part of the appeal of Cloud Volumes that is all ONTAP behind. Is that a similar experience for replicating from NetApp Array to NetApp Array, and that it's the same replication scheme, et cetera? Like, what is the experience of the back end?
Yeah, so if it is SnapMirror, which is a replication engine that comes with ONTAP, and you've got SnapMirror at point A and ONTAP in point A and ONTAP in point B, then the chosen orchestration of that replication will be SnapMirror by default. If there's a discrepancy, and if there's replication that the customer wants the data moved, but it can't because do it using SnapMirror, we've got other options. So there's Cloud Sync will actually read the file content from A and rehydrate it and bring it across and put it into point B. Not necessarily the same levels of efficiency, and there's a mediator in the middle for Cloud Sync that takes the data from the source, does a bit of efficiency kind of work to actually make sure the ingress into the hyperscalers is small, so it could be completed sooner. So that Cloud Sync broker improves the process somewhat, but it is not necessarily as efficient as SnapMirror, which is a core ONTAP replication. Does that answer your question?
So I guess the question then becomes, what cloud providers do I have the Snap option versus the file-based option?
What Snap providers? Hyperscalers. So anything where it's Cloud Volumes in the source and destination.
Okay.
And which, again, we're covering them all nowadays. So that replication orchestration will be done by the Fabric orchestrator.
Yeah. I just wanted to ask that, all of this is great. Obviously, my view is that this is about choice, giving your customers choice to, if they want to go into these services, then you already have something for them.
Yeah.
But I just wanted to hear from you, what was the business driver to actually move into these kind of services? Is it for existing customers or attract new customers? What is the reasoning behind taking this approach now?
Yeah, that's a great question. So it is both of those. It's to help our on-premise customers who have requirements to move to an OpEx model. The easiest OpEx choice for them is to go to a hyperscaler. So they, like 40-something% of customers have a plan. That some of them are, like 40% are already dipping their toes in or actually actively using the cloud. So if NetApp didn't take the approach of having our storage available where customers were landing, then we'd be stuck in the on-prem world. So it was a good business strategic move to actually have our equipment where the customers are going to be, knowing that cloud was going to be so popular. That was the business driver for NetApp to be there, and it not only assists our existing customer base and not losing our customer base to the cloud migration activities, but there is a large population of customers that are cloud native. Like they may have never, they don't care about hardware. They don't want hardware. They just want an amount of space at a speed, and the speed that we can provide in our operating system with our hardware is significantly faster than what the hyperscalers are able to provide using their storage infrastructure. So we can help the hyperscalers attract more customers based on our performance when they layered our services underneath. So that's just another good business case.
Yeah, because
and place to be.
If customers want to use your services because they have choice, that's like Ned was saying earlier as well, that they have other services, similar services that they can also subscribe to. Just to switch to NetApp flavor of, say, Kubernetes, they will have to, first of all, know if there is a commitment behind it longer term, go in this direction. But also, why would they switch to you or choose NetApp for their infrastructure? So hence my question that,
Yeah, no, it makes sense.
What gives them the motivation to,
to move? So yeah, if they going back to those other points before, like if they want to avoid lock into a particular cloud or particular flavor of Kubernetes, and they want to stick with the vanilla version, that we're providing that vanilla version across the hyperscalers, so they're not getting stuck in one hyperscaler. So what if one of them disappeared? Like not saying they will, but there's the freedom of choice basically. It makes good sense for a lot of customers. All good?
Thank you.
Yeah. All right. Let me skip it back to where we were. So I mentioned before the 10 steps to get to the cloud. So I'm introducing an 11th step, going past that to actually convey what's next, essentially. So last year, you may have heard at our Insight conference, we were still thinking of the data fabric as a concept, but we introduced Data Fabric 2.0, which was not a long-held name because we kept working on the product and actually called it the Data Fabric Orchestrator, which that was announced in June 2019. In October, when Insight comes along, the new name is called NetApp IO. Might seem like an interesting choice of name, but if you're familiar with internet domain names, a lot of the domains like .com, very, very common. .io has been coined by a lot of startups and entrepreneur kind of transformational businesses to be different than a commercial enterprise, because they might have been an open source product and they didn't have a commercial interest, so they needed a different domain name. And for a bunch of IT people, IO kind of made sense. It was a somewhat technical term, and we're using it for a couple of those reasons, because this is a new venture. It is something new for NetApp to deliver to the market, and storage is measured on performance, which is measured on IOPS per second, IOs per second. So made sense for a storage company, and so we're wanted to use it as a descriptive name a suggestive name versus a descriptive name. If you're familiar with like marketing terms, subscriptive names are things like Azure. They don't describe what is Azure. Like, you have to be told. Someone has to suggest what the meaning might be for you. Whereas if you go with a descriptive name, like a lot of our products have been to date, and even AWS, Amazon Web Services, that describes what it is, whereas Azure went with a suggestive name.
Just for the record, they stopped there.
Sorry?
It's true.
Just for the record, they stopped there. Then after that, they named everything.
Every single service
Everything
in Azure is
everything else
exactly
was
Yeah.
like,
Yeah, they tried to stick with Elastic.
how is
there.
Lambda functions as a service? I don't know. But
But
Yeah.
Azure Functions are Azure Functions.
But yeah, they also have Azure Stack. They're using it a bit for the on-prem side of things. So we wanted to define something new that encompassed a different view of our product suite. And at the same time, Gartner's actually creating a whole new category for data fabric products. And so it just shows how the impact of the strategic view of what a data fabric is, that Gartner recognized a series of products that exist both in the pure like storage space, but there are some like database companies and analytic companies that use the term data fabric to convey kind of a different message where they're stringing together tables of information within a database and applying metadata, and they're creating a fabric at a whole different layer, but it is related to that same concept of data moving in and out from A to B and back. So step 11 is essentially helping customers move not only just to a multi-cloud, but taking them to a whole data fabric and coining the term that we're creating fabric-wide services. So we're encompassing or wrapping multi-cloud capabilities into a customer's data fabric and giving the ability via NetApp IO to enable fabric-wide services with data movement and flows and policies and things, which I'll get into about how the orchestrator and NetApp IO does that kind of work. But it's an extension of the concept of not that cloud isn't just the end game. Getting to multi-cloud isn't just the end game, but there's still more things that can be enhanced by embracing the data fabric.
So, Neil, I don't necessarily disagree that data fabric is, as a concept, is a critical part of hybrid cloud, multi-cloud path. I just argue that you should probably start with data path versus ending step 11 is data path. I argue that that's kind of too late. If you've gone through all these steps and now you get the data path, you're kind of
for what it's worth, everyone's gone through all these steps and they're just discovering data path. So
yeah, and
fair enough.
They're discovering how complex it is and the fabric that they've woven already just by building it without having an overlaying orchestrator.
Yeah. So my argument is probably if you're thinking you're just starting now, you should probably start with data path.
most of us were always looking at this. It's 1,000 years ago, and like, how are we going to make these pyramids work for us? Versus anyone who's entering the journey now, which is great. It's like you can jump straight to 11. Whereas the rest of us are like, we're at negative 100. We're working our way up to get to 0. It's sad because it's so true. I mean,
It is. I am shedding a tear.
Yeah. And so this is it's not meant to be readable, but this is a view across that kind of fabric-wide ring that goes around the multi-cloud, hybrid cloud, private cloud, on-prem, on-box. That these are a list of all the other NetApp products, and I've kind of pegged them into the different areas with what ring they kind of exist in at the moment, and it's a good story to tell. It shows that we're not just all of our stuff is not just bunched in one little ring on-prem, but all of our products are expanding to assist customers where they are and going beyond that by creating this fabric orchestrator. Question?
So I see on-prem, private cloud, hybrid cloud, multi-cloud.
Yeah.
One thing I don't see on there, and it's something that keeps coming up, is edge. And obviously there's different definitions of what edge is, but I'm curious if NetApp has thought through some ways that they could get into the management of that storage that exists in something like a very small data center, or
absolutely.
something where there's a collection point for a bunch of IoT devices or something along those lines.
Yeah, and I've heard our cloud infrastructure business unit talk about
Would you like some bacon?
their devices, so their HCI equipment being capable of being deployed as an edge device, so in a very small form factor, which they're releasing more denser and lighter weight options for HCI that will suit the edge, but they're still going to be running the HCI stack. Based on that, they'll be able to run it NKS. Based on that, they'll be able to have containerized apps on the edge that could run the Cloud Volumes engine, which could replicate the data back. So there's it seems more like a hardware footprint form factor where what suits an edge case or an edge cloud, whatever you want to call it. But it is having the same software stacks from top to bottom that are also on-prem in data centers and in the cloud is really going to help that extension of the data fabric.
The plane and the management layer are the things I'd be thinking about most, because if you have a lot of these endpoints, you need something that can be the control plane, policy engine, and management overlay for all of them.
Exactly. That's a great segue into what we believe as the way to go for the catering for those orchestration and policy engines is our new platform called NetApp IO.